Next, let's consider an example where we first rotate the region around the x-axis and then consider the region rotated around the y-axis, where we have the function y is equal to 1 minus x squared over the interval from 0 to 1. Let's draw a nice sketch first. 1 minus x squared looks something like this. This is the ordered pair 0, 1. This is the ordered pair 1, 0. So if we rotate this region around the x-axis, then we should get this bowl-shaped looking object. Where the thickness of each slice goes through the x-axis and the radius is determined by the function itself. Hence, the volume will be given by the integral from 0 to 1 pi times 1 minus x squared dx. Now we can bring this pi up front and FOIL this term, 1 minus x squared times 1 minus x squared. That gives us the integral from 0 to 1 of 1 minus 2x squared plus x to the 4th dx. Now we can compute the antiderivative. We get x minus 2/3 x cubed plus 1/5 x to the 5th evaluated in between 0 and 1. Now we can plug in 1 and subtract when we plug in 0, but every term will be 0 when we plug in 0. So we get 1 minus 2/3 plus 1/5. Now we can find a common denominator. Looks like our common denominator will be 15. It's 15 over 15 minus 10 over 15 plus 3 over 15. So that 15 minus 10 is 5 plus 3 is 8. We get 8 pi divided by 15. Now let's try this problem another way, where we can find the volume of the solid when we rotate the region about the y-axis. Let's first start with our picture again. So the nice symmetric region when we rotate around the y-axis should give us something that looks like this. Again, looks kind of like almost like a cone, like the tip of a bullet, with a much smaller opening this time as compared to when we rotated around the x-axis. So it looks like this gives us a completely new object. Now if we cut this thing into slices, the thickness of each slice goes through the y-axis. And now in terms of the x variable, this is the ordered pair x, 1 minus x squared. But if we have the volume of the object by rotating around the y-axis, then we need a dy integral since the thickness of each slice goes through the y-axis. That means we need this ordered pair in terms of the y variable, or we need the inverse of this function. What we have is that y is equal to 1 minus x squared, and therefore x squared is equal to 1 minus y, and x is equal to the square root of 1 minus y. So then, if we plug in the y, we get the corresponding x value as the square root of 1 minus y. So then the radius is given by the x value, which is precisely the square root of 1 minus y. We set up our integral. This is the height 0, and this is the height 1. So we integrate from 0 to 1, pi times the square root of 1 minus y squared, integrated with respect to y. Now let's simplify, bring the pi out front, integral from 0 to 1 of 1 minus y dy. Now we can compute the antiderivative. we get y minus 1/2 y squared, evaluated from 0 to 1. Plug in 1. Subtract when we plug in 0, we get 0. So we get pi times 1 minus 1/2, or we get pi over 2. Now for part C, let's just consider the pictures that we've drawn for each region. In the first, we got this large bowl-like object by rotating the region around the x-axis. And when we rotate the region around the y-axis, we get this kind of bullet shape. So why do they not have the same volume? It's because this is not a symmetric region, and therefore we get different objects when we rotate around the y versus the x-axis. So this concludes the lecture for sections 5.3 and 5.6. See you next time.